on this. Okay, so we are talking about the sampling and how do we compare them to know if this sample is a good sample or is something that we can work with or is just a chance. So we're comparing those two together. Uh, so when we're comparing things, when we pick up a sample, of course, having a good sample, of course, is always important. But the bottom line is there is no way that we can get all the data that we need. So if we really want to create a medication that works for everybody, that means we have to try that medication on everybody in the world. That's not practical. We cannot do that. Or if I want to get some kind of a data from the people, I have to go and get data from every single person. And that's not going to happen. So what we're going to do is we're going to get a sample. Now we're going to verify that sample to see if this sample is going to be a good sample that we can draw a good result out of it, or it's not. Is this so? How do we do that? We're going to create our hypothesis. We're going to say, okay, this is what we're thinking, and then we're going to prove it if it's wrong or if it's right. Now, because we don't have access to every data, we're going to start with some data, and if that works well, then we can go higher and higher with bigger data. That's what happens in medical medicine field. So they try it in lab with animals, then they try it with some people in real life, and then they try with more people. And of course, any scientific material is going to be challenged by uh, peer reviews. Peer reviews are scientists who are going to look at your findings and they critique it for you. So they try talking against it. They don't come and say, hey, I agree with you. So they try to prove it wrong. And all of these things going to come up to a medication. But in the medication, it's going to say in there, it may cause this and this and this and this. If you listen to them in the advertising, is okay, if it's causing all of these things, why should I take this medication? They are not saying that it's going to happen to everybody. What they're saying is we, in our study, we have this percentage of the people may have these issues. So if you fall into that percentage, you might have that issue. That's why they say work with your doctor and figure out. And if you are in that percentage, then it's okay. Till they figure out how to make medication for me only, that's the way we can work with. Now, so they are doing observation with this thing in one hospital. They want to know if a smoking mothers gonna have smaller children. So they go to this hospital. They chose about 1,100, 1,200 newborns. They get the data from the moms. And of course, when you're getting data, you have a lot of stuff in there. The age, height, weight, but the focus in here is about smoking. So when we're doing this testing, we are focusing on the smoking. So we're going to divide the sample that we have, a smoker versus non-smoker. And then we're going to look at this. And when they did that, they figure out that the non-smoker children are about 9 pounds bigger than the smoker children. Okay, is this a fact? Is this something that's going to apply to everybody in the whole world? How do we figure this out? Okay. Remember, there are some other factors in here that we can go look at it again. But let's say about the smoking and non-smoking. Sorry about that. Okay, so how do we figure that out? So, okay, we are looking at about 9 pound difference between the children. What about if we randomly pick up children that are born? Are they going to be randomly having a difference of 9 pounds. So the hypothesis is, if we have a sample and we randomly collect babies, they would have a range of 9 pounds. If that's the case, then the smoking and not smoking is not going to be the effect of what we're looking for. Yes. Oh, I'm sorry. So what they did in this case is says, okay, what we're going to do is we're going to relabel these things. So we have a sample of, let's say, 1,200 people, smokers and non-smokers. We're going to take the labels and randomly assign to the. So the people were a smoker, non-smoker. They can be either way. So they can be, uh, we just labeled. Now we pick up random numbers for them. So remember, the goal is we want to figure out if we can randomly find 9 pound difference. So we create a sample, and because we know about the simulation, we're going to run this 5,000 times. The computer can do this in simulation. And when we do that and we find averages, the averages are almost zero. So meaning that they don't have that average of 9 pounds. So that shows the 9 pound can be a factor of the smoking. Now, researchers don't stop over here. They said, okay, there are some other factors in here too. What about the age? What about the stress? What about the way they're working? If they are working or not working, or other factors that can get involved. So they change this test to, let's say, age. Okay. And they run it the same way. So let's say figure out about the age. So they figure out that most of the smokers are younger females. They conclude that most of the smokers are younger, and they run the same test with the age, and they figure out, okay, that is not directly connected. So the hypothesis is going to deny again. But again, this is just one hospital in one location. So if I really want to do this, I have to make my sample much larger or define the way that I pick up my sample. Even though in this way, we are randomly figuring out if this is correct or not, then maybe the question from a researcher is going to be, okay, maybe this area is going to be different than another area. Maybe if we are in a economy, I'm trying to figure out the good words to say these days, challenged area versus another area could be different. We can test that. Does money has an effect on this? So do the rich smoker mom gonna have a smaller babies? So we can add those stuff to it. So in here, they have much smaller sample. They just say, you know what, we're gonna randomly pick up 31 people. And we're gonna ask if they are a smoker or non-smoker. And they get the data. How do we know this is good or not? We do the same thing again. We're going to relabel them. We're going to pick up samples. We're going to try it again to be sure if that range is going to stay or not. So one way of doing these things in a medical field, they come up with a way to do for the treatments. So when they say, okay, we have this new drug. We're going to try it on the people. People, please come in and try this drug. We want to know if the drug works or not. So they divide people in half. They give half the actual medication. They give half just the salt water. Neither the patient or doctors or any in that area would know the difference. So the treatment would be for the patients would be exactly the same. So they come to the doctor, they say, we have a back pain. This medication is for the back pain. Take it and see how it's going to work. And then they get this data and they conclude something. And now we want to be sure that this was a good sample or not. So comparing this with the previous one, when we did the work on that one, with the smoking, we had self-selected people, whoever wants to do it. Here is randomly assigned. So you come in with a back pain. We are not actually giving you any medication. We just give you salt water. And some people actually psychology get better with no medication, thinking that they are taking the medication. So in the smoking part, there are some other factors available, the diet, the age, the stress, the way of living, and all those things can come in play. And in here, because we are randomly collecting them, we are reducing those things down. Is it possible that somebody comes in with a lot of pain and somebody comes in with a little bit pain, and then we give a medication for this one works, for the other one doesn't work, or vice versa? Yes. But then from the sample, we're going to figure out if that's going to be a good sample or not. So we call this association, we call this causation. There was an issue a few years ago that came up and say, hey, in the final NFL, actually, I should have put my personal opinion about this. Anyway, so on the championship, it came up that hey, they are deflated their ball, and then they had to do a research if it's not going to affect anything or not. First of all, and second of all, how random is that? Was that happen by chance? Like it could happen on without a chance. Okay, so the average drop for Colts was 0.47 psi. The average for the Patriot was 1.2. So they had the balls, and then during the game, it dropped. The pressure dropped. For one team was 4.7, the other one was 1.2. The difference was 0.73. Now, we want to know if this was just by the chance or this cannot be by the chance. So how do we do that? If we want to know if it's by the chance or not, what do we do before? So do we do this? We want to create a null hypothesis that say if we randomly have balls and we pick up from them, there is a possibility that we would have an average of 0.73 psi. Is that true or wrong? Okay, so that's what we want to do. So we can collect all the balls from both teams. Let's say they have 10 balls here, 10 balls over there. And we take the labels off and say, okay, we have 20 balls and we can relabel them or we just randomly pick them up. And then we find the averages and then we run this multiple times, 5,000 times. to figure out if we can recreate this difference. So when we did that 10,000 times for 15 football, the p-value was 0.0026, very, very close to zero. That means the average generally is next to zero. That means we picked up 15 balls and we checked them pressure, and then we repeated that 10,000 times, almost zero, meaning that 0.73 is way outside of our normal curve, concluding that this is not by chance. We cannot recreate this by chance. That's what we're proving over here. So something went wrong. So with the public health, we do observational permittive test, that's association. With medicine, we do randomized trial. We do the permutation test, that's causation. With the sport, we do observational permittive test, that's association. Okay, that's what I have for you on